Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 4, Lesson 18. Let's get started. All right, we're going to examine each of the graphs and their equations, identify the coordinates of the point where the line intersects the y-axis, and then describe the relationship between the point and the equation y equals mx plus b. All right, so let's look at the y-axis. So here's the y-axis. And then I'm trying to find a point that intersects that. Well, that would be this point. Okay, and that point is the point 0, nowhere left or right, and then up 3, so 0, 3. Okay, so there's the first one, and then let's look at graph B. Here's my y-axis. And the point where it intersects the y-axis is here, and that is the point 0 left or right, and then up 7, so positive 7. Okay, and before we do that, I want to do the next two, C and D. So let me move over there, and again, I'm going to look at my y-axis, which is here, and I'm looking for a point that intersects that, and I see that one's right here, and that is the point, well, 0 left or right, and then down 2, so a negative 2. And then one more, we've got the y-axis is here, and we're looking for the point that intersects that. That's this point right here, and that's the point 0 left or right, but down 4, so that's a negative 4. Okay, so let's go back to the first two, A and B, and we're going to describe the relationship between the point and the equation in slope-intercept form. So y equals 1/2 x plus 3, and what I do notice is this. My y value in my ordered pair is a 3, and so is this. My y value in the ordered pair is a 7. And look in the equation. Let's see if that's true on the next two, C and D. The y value is a negative 2. There it is in my equation. The y value is a negative 4. There it is in my equation. So that's happening every time. So let's remember y equals mx plus b. We already learned in previous lessons that m is the slope, but we've never talked about this b. What is that b? Well, b is the number we're talking about. Look at that, negative 2, negative 4. On the previous one, it's the y value. It's where the line crosses the y-axis. So this is called a y-intercept. And that's where the form of the equation gets its name, the slope-intercept form. The slope is included. It's the coefficient of x. And the y-intercept is the constant at the end of the equation. Whatever that is, that's where the line crosses the y-axis. All right, so now if we see a line in slope-intercept form, we should be able to say exactly where that line crosses the y-axis. And here we do. We have y equals mx plus b. So I know that b is a positive 1, and that means I'm going to cross the y-axis at positive 1. I know that's one of the points on my line. Now, how do I know that? Well, remember, we called this the point that's 0 left or right, but up 1. So let's put a 0 in for x and a 1 in for y and see if it makes this equation true. 1 in for y is equal to 2/3 times 0 for x plus 1. And look, we get 1 equals 2/3 times 0 is 0, and 0 plus 1 is 1. We get 1 equals 1. So yes, that point is a solution. It's on that line. Okay, and now I just need to name the y-intercept. Well, the y-intercept is 1. y-intercept is equal to 1. And I need to name the slope. Well, the slope is the coefficient of x, which is 2/3. So now I have the slope, I have the y-intercept. If the y-intercept is at 0, 1, and the slope is 2, 3, that means I would go up 2, and then I would go right 3. And that would be the next point on my line, and I can draw this line right through there. All right. Example 2. Graph the equation y equals negative 3x minus 2. Name the slope and the y-intercept. Well, right away I can name the slope. The slope, if I use a pen, the slope is equal to negative 3/4, right? That's the coefficient of x. And the y-intercept, b, is this constant, negative 2. All right, now I can graph just by using those two pieces of information. I don't need to find ordered pairs. I can just use the y-intercept. I know that it's going to cross the y-axis at negative 2. That's here. And then I know the slope is down 3 and to the right 4. Down 3 to the right 4. That's my next point. And then I can draw the line. All right, next one. Example 3. Graph the equation y equals 4x minus 7. Name the slope and the y-intercept. All right, so the slope, m, is equal to the coefficient of x, which is 4. So the slope is 4. And b, which is the y-intercept, is negative 7. So I know that this line is going to cross the y-axis at negative 7. There's one of my points. And the slope is up 4, right 1. Up 4, right 1, puts me there, and here is my graph. Kind of missed a little, but there you go. Next, graph the equation y equals negative 3x plus 6. Name the slope and y-intercept, and graph the known point. Got it. All I need is slope. Slope equals the coefficient of x is negative 3. The y-intercept is whatever that constant is. It's a 6. So there's my slope and y-intercept. I know I'm going to cross the y-axis at 6. And I know I'm going to go down 3 and right 1. Down 3 and right 1 is my next point. And there's my graph. Okay. There we go. Number 3. The equation y equals 1x plus 0 can be simplified to y equals x. Graph the equation y equals x. Okay, name the slope and the y-intercept. Let's do that first. Well, the slope is the coefficient of x. Well, the number in front of x is a 1. So the slope is 1. And the y-intercept, b, is the constant. Well, there is no constant. It's plus 0. So the y-intercept is 0. Okay, then I can graph the line. I just say, well, it's going to cross the y-axis at 0. That's that point. And then the slope is up 1 to the right 1. And there we have it. That's it. Okay, and then I can draw that line. There we go. Next. Graph the point 0, 2. All right, 0, 2. 0 left or right, 2 up. That puts me right here. Find another point on the graph using the slope 2/7. Well, remember, this means up 2 and right 7. Up 2 and then right 7. 1, 2, 3, 4, 5, 6, 7 goes to right there. That's another point. So that point is the point 7 to the right, 4 up. That's a point on the line. And then we're just going to draw the line. So let's see if I can get this pretty close. That's not bad. Okay, looks like that. Next. A bank put $10 into a savings account when you opened the account. 8 weeks later, you have a total of $24. Assume you saved the same amount every week. If Y is the total amount of money in the savings account and X represents the number of weeks, write an equation in the form Y equals MX plus B, slope-intercept form, that best describes the situation. Okay, so our equation would be this. I'm going to use the slope-intercept form, Y equals, let me get my pen, Y equals MX plus B. I'm going to substitute what I know from this question. And I already know the total amount. The total amount is $24. That's Y, so I'm going to put a 24 in for Y. I don't know the slope, so I'm going to leave that alone. I do know how long you've been saving, and that's 8 weeks. So X is the number of weeks. I know that's 8, so this is multiplied by 8. And then plus B, well, that's the amount that I put into the bank to begin with. That's the $10 that I initially put in the bank. And now if I solve for M, that means I'm going to try to isolate M. So I'm going to subtract 10 from both sides. And that gives me 14 is equal to 8M. And then we'll multiply by reciprocal to isolate the M. And that gives us the 8s will cancel. I get M is equal to 14/8. And if I simplify that, what that would be 7/4. Divide them both by 2. So the slope is 7/4. And now I can write the equation. The equation would be Y equals 7/4 X plus the Y-intercept is the amount of money I put in to begin with, so it's plus 10. All right, so there's our equation. The slope is 7/4. The Y-intercept is 10, and I get that from my slope-intercept form. And then we can graph it. Well, in order to graph, I just need to find where it crosses the Y-axis. That's at 10. And then follow the slope. The slope is up 7. So from 10, we'd go up to 17. This far, and then that's right 4, and right 4 would be all the way to here. So there's my second point, and then I can draw a line including both of those points. All right, there we are. That's the slope-intercept form for exercise number 5. Next, number 6. A group of friends are on a road trip. After 120 miles, they stop to eat lunch. They continue their trip and drive at a constant rate of 50 miles per hour. Let Y represent the total distance traveled and X represent the number of hours driven after lunch. Write an equation to represent the total number of miles driven that day. All right, so we're going to make an equation in slope-intercept form. I'll put it over here. Y equals MX plus B, where Y is the total amount of miles, and X is the number of hours driven. So we have Y represents the total distance traveled, and X represents the number of hours driven after lunch. Okay, so let's identify the slope this time. I know that I'm going 50 miles in 1 hour. And that's going to be my slope, 50 miles per hour. So I can write Y equals 50 times X. And then we're just talking about the miles after lunch. And that means in order to get our total distance, we're going to have to talk about these 120 miles that they drove before lunch. So the after lunch is going to be included, but we also have to include the miles that they drove before lunch, and that's by adding 120. So Y equals 50X plus 120 is our equation. That gives me the slope is equal to 50, and the Y-intercept is equal to 120. That's where we're going to cross the Y-axis. All right, and then we're going to graph the equation on the coordinate plane. Well, I just know that I'm going to cross the y-axis at 120, so I know I've got a point here, right there. And then I'm going to go up 50 and right 1 hour, up 50 miles. would put me at 170. That's going to be all the way up to here. And then right 1 hour is just to here. So my next point is there. And now I can draw the line connecting those points. And that is the equation y equals 50x plus 120. And then we can use that to answer part D. And part D asks, could any other line represent this situation? For example, could a line through point 120 with a slope of 75 represent the total distance that the friends drive? The answer is yes, if they're going 75 miles per hour. If they're going 75 miles in 1 hour, then this slope is going to be different, right? We would, instead of going adding 50, we would add 75 to 120. That would put us at 195. So we would go up to 195, would go up, way up here, almost to 200, and then right one, and this would be our next point. So yeah, the line could be different if they're going faster, right? If they go faster, then they're going to go farther in the same amount of time, and that's going to give us a different slope and a different line when we graph it. Okay, that is lesson 18. I hope that helps. See you next time.